Right, first of all, thank you everybody for turning up for this talk. I have stuffed the audience with people who work for our company, so that's why there's a lot of people in the same t-shirt as me. First, I'd like to introduce myself. My name is Louise Webb. I'm Director of DRLC. It does say doctor at the front of my name. That's because my original degree is in medicine. Then I went into IT, and now I'm training to be a building services engineer and working in ventilation. Why? Who knows? But look at all this grey hair. I'm going to introduce the topics that I'm going to talk about here on this slide. We're going to talk about the background to ventilation in healthcare. Why do we care about ventilation? Why is it important? A quick look at a traditional ventilation system. Those are my words, so you can query whether or not I've chosen a good example. And I do welcome people in the audience asking questions when they come into your mind. I don't want you to wait until the end. I would like you to put your hand up and say, Louise, what does that mean? Or, I don't agree with you, because I would like this session to be interactive. We've all had a bit of lunch. We might all be feeling a little bit sleepy. And, this is all about us learning from each other. Approved Document F, I'm going to mention. That's a new version, came out in June 2022. And I recommend that you all have a look at it, because it's quite radically different from the old Approved Document F. I'm going to talk about a product, which I'm looking across there now at the Air Sentry stand. They haven't paid me, honestly. It's called Genesis, and it's got an Aristotle unit. I'm going to touch on it very briefly, but I know there's people in the audience here, and there's someone on the stand who can talk about it in more detail if that wets your whistle. I'm going to show you some very compact air handling units, one made by Deos and a MedXS unit. And last but certainly not least, I'm going to talk about a very new, I'm calling it a UCV canopy, but I know it's not quite what it's supposed to be called. It's the Opegon temperature controlled airflow. I'm very pleased to say that Peter from Invidicare is sat at the front here with his hand up, and he would be more than happy, he's the director of Invidicare, more than happy to talk to you about this innovative product at the end of the talk. So, background to healthcare. This picture was taken this summer in the 1940s event. If you were that patient, you wouldn't need ventilation because you're getting a lot of fresh air. But things have moved on. Most of our operating theatres are underground, have got roofs and walls, and we need to make sure that the air within that is clean. So this is from the Lidwell report, written in 1972. That's not that long ago, is it? 1972. The main requirements are that air should flow from cleaner to less clean areas, even when a door is open. The rate of air change should not be less than 20 changes per hour. This report had 7 pages, that's all. And it was the start of what we now understand to be critical ventilation in hospitals. So here's a bit of a list. 1983, and I'm going to name check someone now. Ventilation in operating departments, DV4, and sat on the front row is our very good friend David Richard, who's just told me that when he first started in hospital engineering, he used the DV4. In fact, he went through it with a pencil and annotated it and changed it because it wasn't correct. Is that right?
Yeah, and the formulas at the back.
The formulas at the back were wrong. Then we moved on to HTM 2025. There are still hospitals today, I'm sure you'll be aware, running ventilation that is built to that standard, 2025. HTM, Health Technical Memorandum 0103, Part A and B, that came out in November 2007. And that's the one that most people's ventilation, that standard is that they're compliant to. Well, that was updated in June 2021. A bit of unfortunate timing, because we all know that prior to that we had the COVID pandemic. Unfortunately, because of the way these things roll and how long it takes to get something changed, that memorandum doesn't really have anything in it about COVID-19. But that's just the way things happen when you're trying to get a big document together. And if anyone here knows Malcolm Thomas, who was the lead author, he's very frustrated about that. But that's how it is. They may be bringing out an addendum. That's what I've heard. So here I've put a traditional ventilation system, which is a long unit, possibly with 2 tiers. The filters are often monitored with a magnehelic gauge, shown there on the right, and that should be linked to the building management system if it's less than 30 years old, or it might just be standalone. That magnehelic gauge picture is there on purpose. By the way, can I just say all the photos in this presentation, apart from the ones of specific units, are photos that I've taken myself. So these are all things that I've seen in hospitals over the last 2 to 3 years. That magnehelic gauge is what they call unmarked. Where's my Air ISQ friend? How many times do you write unmarked on a verification report?
Well, taking it off now because it can be on the BMS, can't it?
Ah, right, so he's one step ahead of me. So they used to write in verification reports all the gauges are unmarked because it doesn't show whether it's clean or dirty. But Gareth's just told me that nowadays they assume that that is connected to the BMS system. And do we all know what assume does? Do I need to? Yeah. Yeah. So if we assume that's connected to the BMS and it's not working, it's pretty much useless, isn't it? There's no point to it. Here's a couple of pictures, real pictures that I've taken of very traditional ventilation systems. And David there at the back, David Butler, do you know where that is? Weston Park, yeah. This particular air handling unit is still working, and it's used at a cancer hospital in Sheffield called Weston Park, and it supplies the MRI unit. And that is as big as it looks. It's huge, but it's still working. This one on the left, Mr. Butler? No, he's not. Do you know where that one is? No? That's a room. That's a room. That room is maybe 12, 14 feet high. It's a room that's an intake. It's on the Hallamshire Hospital in Sheffield. And the intakes on the Hallamshire Hospital are the size of rooms. That's what I'm using as my example of a traditional ventilation system. So, approved document F, I mentioned before, there's a new version come out in 2022. It's legislation. This is one of the beauties of building document F. HTMO3 is guidance. Document F is legislation. It makes a lot of indoor air quality. So it's changed the focus. And it talks about monitoring CO2, partly to make sure that the air is of a good quality and partly to save energy. Because, as probably most of you are aware, one of the biggest users of energy in a building in the NHS is the ventilation system. Someone's nodding. Good. So CO2 monitors are mentioned in this particular document. I've got CO2 is measured in parts per million. 400 to 600 is what I've put down as where we need to keep the air. David told me just now that at 800 school children start to fall asleep. So if any of you start to fall asleep, I think we better get a CO2 monitor out and see what the air is like that we're breathing. I got this guidance from the government document on CO2 sensors because I've actually been in a building with the CO2 sensors in, and they were all set up incorrectly. It's like any system. If it's not set up correctly, what good is it doing? And those particular sensors were not set up correctly. One of the main things is don't put them anywhere near where someone might breathe on them, because we know we all breathe out CO2. So if we have a sensor that someone's breathing on, it's going to incorrectly show a high level. Keep them away from windows and doors because the CO2 will be incorrectly low. And any intakes from the air handling unit. But this is the way forward according to approved document F. Okay. This system, I think, is modelled in that stand, I hope. It's an air sentry system that fits into the corner of a room. It's a retrofit where you need ventilation and you didn't have ventilation before. So at the top there, that's where you can connect it to your internal ductwork. In the middle is what is called the Aristotle unit, which is an electronic readout of some of the air quality parameters. And at the bottom there, you've got your low-level air extract. Now, I could be wrong, but I think this might be marketed for nitrous oxide rooms where there's high nitrous oxide, as a way to get around some of the issues that we know we've got with staff who can inhale too much nitrous oxide. So I'll show you a bigger picture of that middle bit. Okay, so sampling the air for CO2 and nitrous oxide, as you can see on the right-hand side there, the readout shows you the CO2 in parts per million, the ambient temperature, and the two different particle sizes, 2.5 and 1, was it 1.1? And then N2O, nitrous oxide. So this, at a glance, even somebody in that room who won't necessarily be an expert on ventilation can see immediately whether or not the room is safe to use or whether it's got higher levels of nitrous oxide or CO2. Like I say, if you want more information about that unit, there's their stand. I had no idea that this theatre and that stand were going to be next to each other. I'd like to say I did, but I didn't. This is a compact air handling unit. This particular one is made by a company called DRLC, and it fits in a very small space. This one's at Sheffield Teaching Hospitals, Northern General, and there wasn't enough space for a conventional unit. Very helpfully, the person who put this in, the project manager, well known to our company, we're based in Sheffield, believes in putting really good signage. So I'm going to move away from the mic. You can read that even sideways, and you can read it probably from a long way away. I like that. I like the fact that you know what that unit is straight away, because that shouts it at you. And that's what the box on the front of that DRLC unit looks like. It shows you where the air comes in. I'll give you a minute to look at it. Where the heat recovery is. Intake fan, extract fan. You can see the air goes up and down as opposed to straight across. Ideally, that would be connected to the BMS. In this case, there was a mismatch between this unit, which was very modern, and the BMS system, which was very old. So, as far as I understand it, they didn't quite get that connectivity immediately, let's just say. But they could walk into the plant room and look at the front of it to find out what state it was in. But that's just what happens when you upgrade technology. You don't always get the things to talk to each other in the first instance. This is another unit made by Medex S. This was a factory that we visited as a company. The factory's in a small place called Barnsley. You could probably tell from my accent, I'm not from the north of England. So that's probably not how people from Barnsley say it. This is another very compact unit, built in the UK. We went to look at it because as authorising engineers, we wanted to make sure it was compatible with HTMO3. And it was. That's the inside of the unit. You can see how compact and sleek it is. All the extract and intake come in the top, and all the pipework was on the side. I didn't take a picture of the side. These are my pictures to show you how compact that was. Finally, UCV canopy. It's called the Opragon 8, and it's a temperature-controlled airflow system. I'm not going to say I'm an expert on this. I had a very quick seminar with Peter online, which was very kind to give us. But this is instead of the traditional UCV hood, and it provides a knife edge of air that goes down and protects the wound area during an operation. It is incredibly innovative, and I think I'm right in saying there isn't a single one yet in the UK. Not yet. But watch this space. But they are used across Europe with how many units? 400 units of these are being used across Europe. I chose this picture advisedly because in this you can see that there's a is it an MRI? CT? Yeah, a COM. Yeah, there's a graphical X-ray machine at the end of the bed, and the knife edge airflow has been tailored to the shape that's required by that. It uses 30 to 60% less air than a traditional UCV. So we're talking net zero now and saving carbon. It's also HEPA filtered air. So it is, I think, betterment rather than, nobody's trying to get around the regulations here. They're actually trying to improve what we've already got. So in summary, we had a whistle-stop tour of a background to ventilation in healthcare. We had a quick look at some traditional ventilation systems. Approved Document F, which is the legislation as applies to ventilation. Sampling the air for CO2 and nitrous oxide using some kit which is across the way. Compact air handling units. There's a lot of hospitals in big cities, for example, London, where they really don't have the floor space when they want to upgrade to put in big units. And finally, the Opragon temperature-controlled airflow system for doing ultra-clean operations. Thank you very much for listening. Are there any questions?